All right, we're going to pull together several things that we've been talking about in the last few units. We're going to talk about how we can convert measurements for scale drawings and maps. So you've probably seen maps before, you're pretty familiar with those, but we're going to talk a little bit more about scale drawings. And to start off with the warm-up, we're going to talk about how many feet there are in a mile. You might win a trivia contest sometime if you know this. Especially in the United States, we measure things in miles quite a bit, so this would be a good thing to know. So there are 5,280 feet in a mile. So 5,280 feet, and I'm going to abbreviate that with FT, equals 1 mile. And I'm not going to write the word mile, I'm going to abbreviate that also. So I'm going to write MI. So 5,280 feet in 1 mile. Next question, how many centimeters are there in a meter? Centimeter, so centi, that's like century, 100 years. So this is going to be 100 centimeters is 1 meter. And again, I'll use the abbreviations for those. So cm for centimeters and a lowercase m for meter. All right, now we're going to talk about some common measurements and some notation and some terms that might come up in building or map making or scale drawings and things like that. So let's talk about the abbreviation for inches. For inches, we're going to do IN and then a period. And then for feet, we're going to do FT and then a period. And then for yards, we usually do YDS. Now, it's a little bit proper to put that period on the end there, but I suppose you could leave it off if you wanted to. And there's another type of notation that we can use for inches and feet that's pretty standard. It might speed things up just a little bit. For inches, we can use kind of like 2 quotation marks, and then for feet, we can use 1. So if you ever see somebody write down 15 and then they put that at the end of it, it means 15 feet. Now, let's talk about what a blueprint is. A blueprint is a drawing. A blueprint is a drawing. So let's write drawing right there. It's a drawing of a building that shows the scale so you can tell how big things are in real life. So we have this drawing on a piece of paper and it represents something in real life. And blueprints, they aren't actually blue anymore. They're usually just printed black and white on paper and that sort of thing. But there's a good reason why they're called blueprints. You might want to ask Siri or Google and find that out. You may win another trivia contest sometime. Now, one problem with real-life measurements, like things like miles and a huge number of feet or lots of kilometers or meters or different things like that, is sometimes they get so big, we have a hard time fitting them on a piece of paper. So to solve this problem, what designers do and architects and map makers do is they scale the measurements down so they will fit on a piece of paper. So somewhere on a blueprint or on a map, there's a key that tells you what the scale is. So let's write the word scale right here. Now, this type of scale is exactly like the scale factors that we were talking about when we learned about proportionality. So we're going to keep that in mind. So here's an example. The scale might tell you that every ½ inch on the paper equals 4 feet in real life, or each centimeter on the paper equals 1 meter in real life, or every inch equals 4 yards, or different things like that. Now, the nice thing about that scale is we can use that scale factor to find the measurements on the scale drawing, or how long they'd need to be on the scale drawing, or to find the measurements in real life, whichever one happens to be missing from the information that we've got. So I'm going to slide down here. We're going to do a couple of examples, but I want you to keep a few things in mind. We're going to be working with proportional measurements. We're going to be working with fractions and decimals. So as we do this, I don't want you to forget about a really important thing, and that is cross-canceling. So let's write the word cross right here. So cross-canceling, and I'm going to show you how this works on this first example. So it says we are looking at a blueprint for our partially finished house, and it says the scale is 1/2 inch equals 2 feet. So a ½ inch on the paper equals 2 feet in real life. And it says on that blueprint, the living room is 5.25 inches long, so 5¼ inches long. How long should it be if we measure the actual wall? So we're looking at the blueprint and we can kind of go over and measure the wall of this living room. We should be able to tell how long it would be. So here's what we've got. We've got this 5.25 inches long. So we've got 5.25 inches, and I'm going to write IN as an abbreviation for that. What we want to do is we want to figure out how many feet long is this going to be in real life. And the key is right here. It's this scale factor. So remember, this is a real life problem. It's a story problem. So we can say, let's do 0.5 inches equals 2 feet. And we can write it like that. Now, here's the trick. We're going to make a fraction out of this. So one of these fractions is going to be 0.5 inches over 2 feet. And the other one is going to be 2 feet over 0.5 inches. Now, this looks really weird. We've got 0.5 over 2, and we've got 2 over 0.5. And what I've done is I've put an equal sign between the two of those. Well, these are in fact equal, even if they don't look like they're equal, because this is the same thing. What it's saying is 0.5 inches on paper is 2 feet in real life. If those two represent the same thing, then putting same thing over same thing is going to equal a 1. Now, sometimes we call this a conversion factor. So let's write the word conversion right here. So this is sometimes called a conversion factor, and you use these a whole bunch in your science classes, so kind of get used to this, and you'll see why this might come up in science here in just a second. So here's the deal. We're going to multiply this by the scale factor, but we have to pick the right one. It's going to be a fraction. It's going to be one of these two fractions, and here's how you tell. We want to cancel off the inches. We want to turn the inches on the paper into some measurement in real life. So we're going to pick this one right here. We're going to pick this second one. So I'm going to put 0.5 inches, and then I'm going to put 2 feet on the top. Now, you'll notice that a couple of things happen here. I can cancel the inches right there. I could also do a little bit of cross cancellation with the decimals and stuff like that, but we're not going to worry about that. I'm going to pull up the calculator and let it do the work for us. And once I've got the calculator up here, I'm just going to go ahead and type this in. Now, because there's no addition or subtraction here, the calculator knows the order of operations, so I can just type this in as 5.25. And then we're going to hit times for that set of parentheses, times 2, and then we're going to do divide by 0.5. Now again, if there were addition or subtraction in here, I'd have to be a lot more careful about the way I type this in, but I'm going to go ahead and hit enter, and I end up with 21. So the answer on this one is, whoops, let me change colors here. The answer on this one is 21, but take a look here. The inches have canceled off. They've cross-canceled, so the only measurement left is feet. So the answer is 21 feet. That living room wall, if we go measure it, it should be 21 feet long, and then we can know that our house is being built properly. Okay, let's slide down here and take a look at the next one. This is a map question. And on this map question, here's what we've got. It says a map legend, and a legend is another name for the key or the scale. It says that half an inch on the paper is 2.5 miles in real life. So if it's 4.5 inches from South Jordan to Pleasant Grove on the map, how far is it in real life? So here's what we want to start with. This is what we're given. So this measurement right here is what we're given, 4.5 inches. So 4.5 inches. Now we're going to multiply it by a scale factor, and a scale factor or a conversion factor is going to be a fraction. So we want to think about this. Are we going to do the 0.5 inches on the top and 2.5, let me get that 0.5 in there, miles on the bottom, or are we going to do the 2.5 miles on the top, and are we going to do the 0.5 inches on the bottom? Well, you guessed it, just like the last one, we're going to put inches on the bottom because that will allow us to do the cross cancellation here. So we've got 0.5 here, and then we've got 2.5 miles on the top. Now I'm going to do some canceling here, so I can definitely cross cancel the units. That's going to leave just miles, but I want you to notice something else. I can cross cancel 4.5 with 0.5. I'm going to do that in just a second, so we'll hold on here. Let's type this into the calculator and see what the calculator says. So I'll clear that one off. 4.5, and we're going to times by 2.5, and then we're going to divide by 0.5. All right, so we've got that in there, and we end up with 22.5. So 22.5. The only units left here are miles, so it's going to be about 22.5 miles from South Jordan to Pleasant Grove. Now, I mentioned before some cross-canceling that we can do here. We can actually cross-cancel or reduce in two different places here. I could cross-cancel the 0.5 with the 4.5. It's kind of like how many times is 5 going to 45. I'm going to change that into a problem over here. I'm going to say that would cross-cancel into 9, and then what would be left here is a 1, and then this would be 2.5. I could also do this. I could cross-cancel the 0.5 with the 2.5. Again, it's kind of like 5 going into 25. So I end up with 4.5 because I didn't change that at all. And this ends up being, let's see, 5 goes into 25. That goes in 5 times. So watch what happens if I pull up the calculator now. I'm going to type the two of those in there. So I'm going to do 9 times 2.5. Got the same answer. Excellent. Let's do the next one. 4.5 times 5. got the same answer. So again, this cross cancellation really comes in handy, so it's a great way to do things. So I'm going to slide down to the bottom here, and this is very, very similar to what you're going to do on your assignment today. It's a relatively short assignment. It's not too long, but you've got a problem like this. A whole bunch of them are the same type of thing. So we've got an architectural set of blueprints for a new school, and the scale is 1/4 of an inch equals 2 feet. So 1/4 of an inch on the piece of paper equals 2 feet in real life. So what I'm going to do, because this is a real world problem, story problem, I'm going to go ahead and change this. 0.25 inches on the paper is 2 feet in real life. So I'm going to use either 0.25 inches on the top and 2 feet on the bottom. Remember, those represent the same thing, so that's kind of like a funny looking one. And then I can put 2 feet on the top and the 0.25 inches on the bottom if I need that. Now, the conversion factor that we use here, it's either going to be this one or this one, depending on what's missing. And let's take a look at this right here. This is very similar to the one that we did up above. Same type of measurement, 5.25, it's inches, and we want to figure out what the actual size is. So I'm going to write down what I'm given, 5.25 inches. And again, the labels are important, so I'm just going to draw an arrow there. And we want to cancel that off. So I need the inches on the bottom. So I look up here, which one has the inches on the bottom? It's that one right there. So 0.25 inches, and then I've got 2 feet on the top. So I grab the calculator. We'll slide this over so it's out of the way. And I'll clear that off. And we're going to do 5.25. Now, if you want to do some cross-canceling, you're welcome to do that. I'm going to times that by 2. I'm going to divide that by 0.25. And we hit enter, and we end up with 42. So the answer on this one is 42. So 42 here, and it's 42 what? Well, remember, we've canceled off the inches, and then we've just figured out what the number is. The number is 42, and the only unit left, the only label left is feet. So we're going to go ahead and label that as 42 feet. 42 feet, and that is the answer. So we were given the drawing size of 5.2 inches, and we figured out that in real life, that music room would have a wall that's 42 feet wide. Now, I just real quickly want to come back up here and take a look. We did have 5.25 here, and this looks like it's similar, but it's a little bit different than the one that we did up here. Notice what the conversion factor is here. We've got 2 feet on the top and 0.5 on the bottom. So because the scale is a little bit different on each one of these, we're going to get a different answer for that one. Okay? All right, let's come down here and take a look at the auditorium. The auditorium's pretty big, and notice what's missing here. What we're missing is we're missing the drawing size. We've got the actual size. We need to figure out the drawing size. So here's what we're going to do. We're going to write down what we start with. We know that we've got 156 feet in real life, or we want it to be 156 feet long. Then we need to multiply it by a scale factor. Okay, so I'm going to do this. So again, I'm taking what we have, I'm putting it right here. And then what I need to do is I need to cancel off the feet so I can know how many inches it needs to be on the actual paper. So I'm going to use the one with the feet on the bottom. So if I have feet on the bottom so it can cancel off, that's going to be 2 feet on the bottom, 0.25 inches on the top, and then we do some cancellation. So I'm going to cancel the feet here. Now those are pretty big numbers. If you want to do some cross cancellation, you're certainly welcome to. I'm just going to pull up the calculator. I'm going to do 156. We're going to times that by 0.25, and then we're going to divide by 2. Hit enter, and we get 19.5. So 19.5, and remember, that's 19.5. The only unit left is inches, so 19.5 inches, and I'm going to put that answer right here, 19.5 inches. So we'll go ahead and circle that. That's a lot what like your assignment is like today. I do want to quickly mention that if you were to use your calculator, let's say we did some cross cancellation here. 2 goes into 156, so we did 156 divided by 2, and maybe some of you can do that mentally, so we get 78, and then we're going to take that answer and we're going to times it by the 0.25 that's left. So 0.25, and lo and behold, we get that 19.5. All right, so I'm going to flip over here. Let's take a quick look at one of the problems on your assignment. So let's take a look at problem number 1. We've got the lobby, and it's actually 15 feet. One of the measurements in that lobby is 15 feet, so it's the same conversion factor here. So we've got 0.25, better make that look right. 0.25 inches is equal to 2 feet. So I've got 15 feet right here, so I'll put the feet right here. We need to cancel off the feet, so that's going to need to go on the bottom. Again, this is kind of like having a fraction there. You can turn anything into a fraction by putting it over a 1. So we're going to put the 2 feet on the bottom. We're going to put the 0.25 inches on the top, and we're going to do some cross cancellation. We can cancel those. And then we're going to grab the calculator again, and we're going to do 15 times 0.25, and then we're going to divide that by 2, and this will tell us what the answer is. So we end up with 1.875, and again, the only unit left is inches. So I'm going to write 1.875. These actually go pretty quick once you get going. And that's how you do it. So you've got a couple problems like that. The backside, there is, I think, a map problem and maybe a rectangle problem where you're converting some measurements there. I do hope that this makes sense, and I also hope you recognize this number right here, 0.875. I'm hoping you recognize that as one of those common rational numbers that we've studied. That's in eighths. So this is actually 1 7/8. So 1 7/8 if we were to write that in fraction form. You don't have to do that. We're just going to leave the answer in decimal format because this is a real-world problem. All right, good luck on the assignment.